Lovely. Thank you very much, Paul. Welcome, everyone. It's great to see so many people here. I've been told earlier today that this webinar has the highest sign up of any EXA webinar ever. So thank you all for that. I think that also shows just how important this topic is and to how many people this topic is very important. So we'll be talking about the role of artificial intelligence in transforming citizen science with a specific focus on privacy, on data sharing, and on open science, which is the working group that has instigated this webinar. We have three fantastic speakers, which we will get to in just a moment. But to get us all warmed up a little bit, I will first hand over to Fotis for some Menti engagement.
Hello, everyone, from me as well. My name is Fotis. I work as a project policy officer at Opera's Research Infrastructure, and as part of this working group, I supported a little bit the preparation of the workshop, of the webinar, and I will now share my screen. And also, please go to menti.com. We will work with a Menti. The code is 57458252. We're just going to share a few. Just gonna work a little bit to some warm-up questions. So you should be able to see my screen now. And you can see in the top how you can access the Mentimeter. I will wait a few seconds to see as many of you as possible in the document. Since this is during lunchtime, we thought to begin the Menti by simply asking what is your favorite meal for lunch. I see some familiar options, porridge, for example, pasta, of course. Is this from Italian audience? I don't know. I don't want to presume. I love pasta, I'm not Italian. Paella, interesting. Grilled cheese sandwich. Potato pancakes with salmon. Ugali, I like these options, but I have to Google them afterwards, what they are. Smalahov, I don't know if I'm pronouncing it correctly. Do apologize for that. Pizza, rice and chicken. Boban, pasticcio, I don't know. Thank you for saying that. I love it as well. So rice and beans from Brazil. Awesome. I've had this in England a few times when I was going to a Brazilian restaurant. Awesome. Many interesting options. Thank you very much. Now I'm a bit hungry. So let's go to the next question. But it doesn't let, oh, there it is. So no, the first, oh, sorry. Where are you joining us from today? That is the first question, just so we know where are you based. It would be nice to see the where the audience is from, which cities, which countries. Which regions. I already see South Africa. Oh, I see a flag there, which I should really know where you're from, but I do not. Spain, Scotland, Paris, Vienna, Valencia, Spain, Athens, Portugal, Switzerland, Ottawa, Lithuania, Dubai, Savoy. Again, really, this part shouldn't have been recorded, but okay. Germany, Cluj, Napoca. This is Romania, if I'm not mistaken. Just practicing my skills, my geographical knowledge. Greece, Kenya. Awesome. So we have a good spread as far as I can see. Of course, we will take some more time to look back when we report a little bit on your responses afterwards, after the event finishes and when we are about to prepare a report for what we're going to do today. So I'm just going to proceed and go to the next question. How would you describe your professional role? This is just, again, very quickly to get a feeling of where you're working, what kind of roles you're part of, so we understand how citizen science or AI is part of your day-to-day. Researcher, citizen science volunteer, awesome, grant researcher, It's the candidate AI research, NGO, software engineers. So we have technical roles, we have less technical aspects, project coordinator, very important. I think nowadays I see AI being more part of how it's going to be managed within projects. I have to review ADMP, for example, and we are going to have a question in that data management plan, how AI is going to be used and overseen and managed within the project. So this is very interesting perspective. Research policy officer, I think policies are very important for AI as well, and how they interact with citizen science. Open science manager, citizen science, his job generally, lecturer. Interesting. I don't know if teaching AI is part of your day-to-day at the moment, or if you're planning to teach AI. That would be interesting to know. Archaeology, I like that. I don't know if any data analysis is part of your, if you interact with AI during a data analysis. Data steward. Data stewards, what kind of advice are you going to give in the next few months and years around AI? That is interesting for me as well. Thank you very much. Concept developer. I see very interesting responses. I look forward to reviewing a little bit more, again, the context of your responses, but I'm moving on to the next question. That's okay with everyone. Do you currently use AI in your work? This is a very straightforward question, just to see if AI already features in your day-to-day life. I offer more options with yes, of course, and then just to capture the breadth of how sometimes we can use AI, but of course, there's an option there to say no. So yeah, the majority is in the yes area, and then we have a few no's as well. Yes, sometimes. Hopefully, we will find out how you're using AI. You will listen, of course, to the presenters, and then the chat will always be available for you to comment if you have any insights, depending on what you're listening from the participants. Again, in the interest of time, I will proceed because I think the results here demonstrate the picture that we are using AI more or less in our day-to-day life. So if yes, for those who answered yes, how do you use AI in your work? I included some examples: data analysis, create code, text generation, but feel free to use your own words. Of course, this is not the only options. It was the first ones that seemed very straightforward to include. Creating mappings of habitats. These are some of these, maybe, when the specification here is a little bit outside of my expertise, but very nice to have that as a response. Text generation, text improvement, content generation, image generation. I think the word generation features very heavily, text or image, text creation. Of course, we have create code, identify species from acoustic recordings. This is very interesting, very specific. Chatbots to find ideas or start investigation into new topics. So that would fit into the research question area, like you're trying to create research questions around that. Create code, data analysis, idea generation, or crystallized ideas and better searching. So as a support, more or less, that's my overview. Streamlining, creating code, debugging, translation. Awesome. I use it for translation a lot, to be honest. Information search, data analysis code. I think the responses are very much, again, similar. Of course, there are some outliers with very specific responses, but I think we get an idea of how that works. And this is a question that one of our speakers added. Where do you think AI adds most value to citizen science initiatives? Again, a few seconds for you to respond, and we have one more question, and then we'll get to the reason why you're here today to listen to our wonderful speakers. So where do you think AI adds most value to citizen science initiatives? Data handling, data analysis. And this is interesting that you're mentioning data, because this workshop was, it grew out of the idea of how we're working with data, and it developed into, the impact of AI in this process. So it's important also, because this is a working group around open science, to think how open science can perhaps support, protect, or provide guidance in terms of how we manage data, because there's a lot of good practice, especially with FAIR principles, with CARE principles, the other aspects of how we manage data. So that's why also we think today this is a very interesting workshop to see how we're interacting with these concepts. Data analysis, instant response and feedback, knowledge sharing. I do not see the value yet. I think CS has a lot to add to AI though. I did think about that when we were putting the questions, that we have to change also the order of the questions. And I think this is also part of one of the presentations. So I really expect more discussion on this today, how citizen science can provide some value to AI, coding engagement, data streamlining, scientific methods, interesting, data handling. So analysis, handling, data, I think it's the most feedback, real-time data, public communication of science. Thank you very much, everyone. I think these are, I think, again, we see a pattern here. And the final question, which I wish I didn't have to close on this. I maybe regret it now. What concerns do you have about AI in citizen science? These are always, part of the conversation around AI. And I see a lot of links, for example, with the previous responses around data handling. Hype, interesting. Hype, in what way? Hype about how AI is here to stay, or if it's too over valued, let's say, in this process. Dignity, privacy, ethics, of course. Data centers consuming a lot of water. Okay, this is interesting. Some side effects that we don't always think, although we know now more and more how much data energy hungry these centers can be. Misinformation, underrepresentation, missing EU sovereignty back-end features, data processing, UX, sustainability. Technology is not always the solution. Ethics, privacy, and security. Very interesting point of view. Citizens no longer feel they need to engage because AI can do things better than them. Ethical integrity, AI might substitute protection. I see more, I think, when I look at them, I see more diversity here in the consensus rather than on the values that we saw earlier. So I think this will take a little bit more time to categorize maybe and code a little bit some of the responses. But as far as I'm concerned, definitely I see ethics more and more mentioned, fake news, data security, and I think this should be all for now. We don't have any other questions. Thank you for the response. As I said, we will provide comments. Yep.
Thank you for this. You broke up a little bit there, but I think you tried to hand back to me. So thank you for that. That was really interesting to see, and also to see the engagement in the chat and people already asking for this data. So I think we will look into that, and it should be possible to provide that alongside the recording. But for now, let us actually start our deep dive into this topic with our first speaker. Our first speaker is Dilek Freisel, who will be speaking about leveraging the collaborative power of AI and citizen science for sustainable development, which if you followed her at all on any platforms, you will know that she has very deep expertise in this area and has been working on it for a long time and across many different publications that I have certainly tried to keep up with. So Dilek, can I hand over to you if you want to start sharing your screen?
Thank you so much, Gefion. Let me try and share my screen. Okay. Thank you again for the invitation to speak in this webinar, and it's impressive that so many people showed up during lunchtime, particularly at least where I am. So I really appreciate that, and thanks for the invitation and for giving us the opportunity to talk about our recent paper. The title of my presentation is The Leveraging the Collaborative Power of AI and Citizen Science for Sustainable Development. And my name is Dilek Freisel, as Gefion mentioned. I'm a senior research scholar at the International Institute for Applied Systems Analysis. I'm also the managing director of the Citizen Science Global Partnership, which is a network of networks that aims to advance citizen science for sustainable development. But probably during the discussions, we will connect that Citizen Science Global Partnership aspect to the AI discussions. So as I said, this is a paper that we recently published in Nature Sustainability just before the holidays, actually. And our aim was to really look at the AI and citizen science and its link to citizen science, but from a different perspective, not this time how AI can contribute and advance citizen science, but the other way around, how citizen science can actually advance AI development and use. So our idea, as Gefion mentioned, I work a lot on sustainable development and particularly the monitoring of sustainable development goals, as well as other global development frameworks, be it Sendai framework, be it Paris Agreement, or many others, or global level urban monitoring frameworks. So we know that sustainable development goals have 17 goals, and under these 17 goals, there are 169 targets and 231 indicators. And we have always looked at how citizen science can actually address the data gaps within this SDG indicator framework. So as I said, there are large data gaps, and we have about less than 5 years left to achieve the SDGs, but data gaps are still very present in terms of better monitoring the SDGs. This is important, and I will explain why. But I would just to highlight data availability issues regarding the SDGs. So this is from the SDG report that is published by the UN Statistics Division, or UN DASA. And it shows the data availability increasing between 2 different years. So it shows the comparison between 2019 and 2024 in terms of data availability as per SDG. So these are all 17 goals. So we see that there's huge progress in between these 2 years timeframes, but still we have large data gaps, and there is no SDG that have full coverage at this point of time. But if you look at particularly the areas, the goal 5, for instance, this is about gender, which is a very important SDG. And SDG 11, sustainable cities and communities, which have a lot to do with citizen science. And goal 13, which is about climate, they still have largest data gaps in the SDG framework. So, and data are still lacking, for instance, for about half of the 92 environmental SDG indicators. But data availability is not the only issue. We also have issues related to poor data quality, because the SDGs are being measured using traditional sources of data, which are considered high quality, but they have a lot of issues in terms of quality as well. And these are censuses and household surveys, but this is a conversation for a different topic and for a different time. But also we have a lack of data sharing and infrequent data collection cycles, for instance, when it comes to household surveys. And sometimes there's like more than 10 years difference between 2 surveys, and where the governments are trying to make decisions, policies based on outdated data. And lack of disaggregated data is another huge problem, and disaggregated by local or other areas like gender. This is very important, because in order to be able to achieve the SDGs, we need to have targeted interventions. So we suggested citizen science as a way to address these data gaps in the SDGs. And I'm not going to go into details of this, but I put the link to this paper in the chat. And this shows, with this paper, we showed 33% of the SDG indicators can actually be monitored through citizen science data, direct or indirectly. As I said, the details of it can be found in this paper. And based on the results of that work, WHO has commissioned to us a study which is about understanding the particular contributions of citizen science to health and well-being related SDGs and WHO's 3 billion targets. And they asked us to look into, to do an in-depth analysis focusing on these kind of indicators. And we found that citizen science can actually contribute about 85% of these relevant SDGs, relevant to health and well-being and 3 billion targets, because health area is also particularly missing a lot of data. And we highlighted that in this paper, like where the data gaps are and how citizen science can actually contribute. And these were so far the idea of how citizen science can actually contribute to addressing the data gaps in the SDGs. But there's also separately in the AI world, there has been some discussions and a lot of good papers on how AI can actually advance sustainable development, monitoring and implementation. And one of those papers, we also reference to this paper in our paper that I mentioned. This is a study that looked at the AI and its potential for sustainability. And they found that 134 targets of the SDGs can actually be supported through AI. And they provided all the detailed analysis. I put this to my slide, but you could have a look at the details of this study. So according to them, AI can enable the accomplishment of 139 targets, but there are also the negative impacts. So there could be targets that AI can negatively affect. Now we have been discussing the separate or individual potential of AI for citizen science and citizen science, AI for sustainable development and citizen science for sustainable development. But we can now have a look at the combined impact of AI and citizen science for sustainable development, and both for the monitoring of sustainable development and its implementation. So as I said, in this paper, we particularly focus on the two main ways to integrate them. So incorporating AI into citizen science and incorporating citizen science approaches, data and principles and approaches into AI. So as you could see in this photo, at this point of time, AI is already being used in citizen science projects in many different ways, and I'm not going to go into details of that. There are a lot of published studies on that in addition to ours. So for instance, machine learning and deep learning assisting with species identifications in projects like iNaturalist and PlantNet, and also AI helping to improve data quality, for instance, in eBird and in GalaxyZoo. GalaxyZoo refine AI-generated classifications through participant feedback. And there are other projects that use AI basically to enhance user experience. So you submit something, your observation, and then you get feedback on the quality of your observation. And then actually this also helps better engagement of you at the same time improving data quality. But like if we look at the future or the emerging ways of AI can be integrated into citizen science. And when I say AI, sorry, I should have clarified that in the beginning. I'm talking about both generative AI, so the new approaches, but also machine learning and all the other types that I put under the term of AI. So in terms of the emerging applications, AI can support citizen science through chatbots and virtual assistants and real-time validations and observations. And you have put some ideas during the Menti exercise, and there were a lot of these actually being mentioned in there. And AI models can also be trained using input from citizen scientists or explain some environmental changes, like biggest shifts in quality, air quality, or weather. So participants can actually feedback on these things and why they are happening in a particular local area. You name it. There are so many different ways AI can actually support citizen science. And in another way, it could actually transform even how citizen scientists interact with citizen science applications and platforms. Maybe in the future, we will see more type of conversational applications, citizen science applications using, in this emerging world of AI and citizen science. So, so far, a lot of the research has explored AI benefits, like how AI benefits citizen science. And this is what I've been talking about so far. But the idea with our paper, how citizen science data and methodologies can shape AI. And this is an area that citizen science community should particularly look at. But like, I will briefly explain what I mean by that. So last year, through the end of the year, we published this study with colleagues from Paris 21. this is particularly, this had nothing to do really with citizen science, or not really directly, but this was basically looking at AI through the lens of official statistics. So national statistical offices or national statistical systems, government agencies that compile data, used official statistics to make decisions. And part of their work is also monitoring and reporting sustainable development goals. So we wanted to understand the risks and benefits of AI for this, particularly in National Statistical Office operations and for official statistics. And we published this study. And for a little bit of context, if you don't know what Paris 21 is, it's basically the Partnership in Statistics for Development in the 21st century. They sit in OECD facilities in Paris. And they are particularly focusing on low and middle income countries for improving the quality and production and accessibility of official statistics. And they were founded in 1999 by the United Nations, European Commission, the OECD, IMF, and the World Bank. So they are particularly focused on, as I said, low and middle income countries. So if you look at this slide, you will see some of the benefits of AI that we risk for this particular group. This is very relevant to what I'm going to say coming up, so that's why I put this on the slides. But there are really benefits, particularly related to data and statistics production. But there's also great risks, particularly in the global south, and this could be widening disparities and amplifying existing biases and privacy and lack of governance of AI globally. So if we go back to this slide again, and what do I mean by the integration of citizen science data and approaches into AI, and why this is necessary? So the previous paper that I showed you, where colleagues discuss how AI can contribute to sustainable development, I mentioned that they found 134 SDG targets could benefit from AI. But they also found that AI can actually impede 59 SDG targets. This is very important. And one example, for instance, use of AI may result in better or higher quality jobs, or higher job qualifications. This could widen already existing inequalities within the societies and within countries and globally. So there is both the contribution of AI, but also how it could impede achieving sustainable development by widening disparities. So here in this slide, I will particularly focus on now the light green part of the figure, which explains why we need to actually integrate citizen science data and approaches into AI, and not only to consider the other way around. So in this particular paper, we focused on 3 aspects. There's probably many more, and you may notice in your own particular area of research in citizen science. But for us, one important aspect is really the lack of local data. So as we all know, AI models require vast amounts of data, and but a lot of the regions of the world, particularly in the global south, there's huge data gaps. For instance, if you look at Asia and the Pacific, in last year, in 2023, 40% of the SDG indicators in this region lacked data, and 10% only had one single point. So we're trying to really achieve the SDGs with no available data. This is really important because you cannot achieve what you cannot measure. That's why I'm emphasizing the importance of availability of data and high quality data. And even when data exists, particularly in these parts of the world, they are fully disaggregated by location, gender, disability, and other factors. And this is really important because it can really extend disparities between different population groups in a country, or in a region, or globally. So AI models, if they are trained on incomplete and non-representative data, there's a lot of risk related to inaccuracy, bias, and widening inequality. So just a quick example, We've done a feasibility study of using drones, AI, and citizen science in Ghana to detect plastic litter from the beaches. And we used a model that was developed in Europe, and we just basically wanted to detect whether this is feasible to use. And for instance, because the model wasn't trained on local data, it failed to identify, for instance, water sachets that are used to sell water in Ghana. So it was good with high accuracy. It was able to identify plastic bottles, like a certain size, but it wasn't able to because it was never trained on this data. So, but we know that in citizen science projects, people go to beaches and they collect data, they take photos, and a lot of these can be used actually to train these AI algorithms for better accuracy and outcomes. And this was just one example in terms of the environmental aspect. And there are a lot of social, ethical related aspects that come with it in terms of the importance of having more local data to improve our results, our scientific results, but also to improve the better monitoring and achievement of sustainable development. And so citizen science can actually help bridge these data gaps by collecting really community level data that focus on local realities, and this could increase the accuracy of AI results. And in terms of societal biases that we addressed in the paper, AI can really reinforce these societal biases, especially related to race, gender, and disability and ethnicity, because of the bias in training data again. And citizen science can actually help to address this by providing more representative data, because we know that citizen science is quite strong and powerful in terms of the local aspects of it. And it can also help to generate disaggregated data that is really crucial for the leaving no one behind principle of the SDG agenda. And in terms of the lack of public engagement aspect, AI development really lack most of the time public engagement. So even though it impacts everybody, only a few people are able to make decisions on its development. So this is also a social justice issue, and particularly in the global south, where marginalized communities are frequently excluded from these important discussions. So there has been some calls from at the UN level, and it focuses on ethical AI governance, and that really focus on multi-stakeholder partnerships, which citizen science can actually facilitate through co-creation and through the involvement of individuals and communities into these discussions. So AI can also help address disinformation, of course, that came up during the mentor results, and also can support democracy, human rights, and many other aspects, because AI can actually, if not designed and used properly, there's a risk, huge risk in terms of use of AI for sustainable development related reasons. So we proposed a roadmap about this integration. So how we can integrate not only citizen science into AI to address, not AI into citizen science to address the shortcomings or issues related to challenges related to citizen science, but also how we can integrate citizen science data and approaches into AI to address AI risks. And I'm not going to go into details of this, but you can have a look at the paper for these more concrete actions about how we can really integrate citizen science and AI. But in terms of the challenges and risks, so, okay, we highlighted a lot of positive aspects related to citizen science, but citizen science is not without challenges. Yes, AI has a lot of risks and challenges, but citizen science do too. So, for instance, if we are talking about societal biases, so if societal biases related to AI may worsen if we do not address the potential bias in citizen science projects during this integration. We know that a lot of citizen science projects are going really above and beyond to address these representativeness or biases related to data. They basically work directly with local communities, or they implement many different ways to, or many different aspects related to addressing these issues on bias in citizen science. So there's still a lot to do on that front, but we need to really focus on that aspect as well. And of course, openness of AI is one issue, but openness, data openness in citizen science is another issue. But maybe there will be another webinar that will discuss this issue. I'm not going to go into detail of it because of the time. And finally, just wanted to highlight this ending of our paper. There is the Pact for the Future, and there is a part of it, Global Digital Compact, adopted by the UN and the countries. And that particularly highlights the global framework for digital cooperation and AI governance. It is really important to govern AI, and it is really important that citizen science community and citizens and communities that citizen science serve are part of these conversations. So that's why we urge all the relevant actors, especially the UN, the policymakers, the countries, to embrace our perspective and the vision outlined in this paper to really involve citizen science actively in these conversations and discussions. I will stop here. Thank you very much.
Thank you very much, Dilek. That was extremely interesting. There's already been a bit of a discussion started in the chat, so maybe you want to have a look at that. I would invite everyone to add questions in the chat as we go. We will have a Q&A and discussion at the end of the talks. So for now, thank you, Dilek, and we will move on to our second speaker, who is Karen Verstralen. Karen is a project manager at Civil, the Flemish Knowledge Centre for Citizen Science, and there she is leading the amai project. I'm sure she will correct me in a moment about how to properly pronounce that, and how to co-create AI for societal challenges and the approach that they use to do that. Karen, please, the floor is yours.
Thank you, Vivian. Thanks again for the invitation to speak. About the name amai. Amai, it's a Flemish word. It means something like, oh, wow, that's amazing. So we say amai. And it also has AI in the name. So that is how we came up with the word, because we also want to create some sense of amazement from citizens around AI and want to make them aware of what is going on with AI and what the possibilities are. And of course, also the risks. And what we want to do is we want to co-create AI for societal challenges. So it is a project where you want to involve the citizens from start to finish in the development of AI applications. The amai team. So do you still hear me?
Yes.
Yes.
Okay. The amai team, we consist of two partners. So myself, as mentioned, I work for Civil, the Flemish Knowledge Centre for Citizen Science. And we work together in this project with the Knowledge Centre for Data and Society. We work together as two partners. We work together really well because of our shared experiences in different kind of projects. And the project is funded by the Flemish government as part of the AI Flanders program. It is actually the outreach component of the AI Flanders program. So what are the main goals of the project? There are three. Firstly, we want to create some insights. So we want to make citizens aware that AI is a thing that is there and how it is part of their lives and what it can mean for them. And that is a science communication component of the project. For the citizen science, we want to ask citizens about how that they want AI to be used for in their lives and how it can be beneficial for them. So we want to go in discussions with them on their ideas for AI, and we want to start with gathering ideas and then further developing these ideas. I will explain on this more later. And then finally, of course, we don't just want to gather these ideas, but we really want to get something out of it as well. We really want the citizens to be able to create impact. And for this, we also have a project call running that makes sure that these ideas from citizens are developed also into concrete applications. So for the target audiences of this project, our main target audiences are, of course, the general public. So we aim at societal implementers. That's a group of people who are not interested in AI or technology already, or they don't have much background in it so far, but they do care about societal themes like climate or health, for example. So through these societal themes, we can sort of convince them or seduce them in thinking how this technology would sort of be beneficial for them as well. And next to that, we also interact with other types of stakeholders like civil society organizations, researchers, AI professionals, and policymakers. And throughout different steps in the project, they all come together and get to interact with each other or learn from each other as well. This is, in a nutshell, how the project works. So there are 4 main phases. We start with collecting research questions from citizens. So those are the ideas from citizens. On AI applications. And then with these ideas, we go to co-creation sessions where we co-create solutions together with different stakeholders. Then we have the open call, and then some of the projects are funded and they get developed. So citizens are involved in every phase from start to finish in the development of these AI applications. I will go a bit more in detail in the different phases. So we start with collecting the ideas from citizens or the research questions. For that, we have an online platform. And you see an example on the slide. Of course, it's in Dutch now. But for example, an idea, the first one is like a smart system that gives suggestions for people with diabetes for different recipes or things that they could eat or when they should eat at what times, for example. So we ask for their ideas in societal themes, and those are the 4 themes: mobility, climate, health, and work. So we have the online platform where citizens can share their ideas, but of course also we have some accessible information on their own AI, because we cannot expect people to just come and share their ideas from scratch. We have some accessible information. We have, for example, stories. There's, for example, a story of a girl who goes to work and she uses the spam filter on her mailbox that filters which emails she gets to read and which not. And then we explain step by step why that is AI and what AI does in this occasion. Another example is we have a short fun quiz. It's a bit like these BuzzFeed type of quiz where you fill in some questions and then you get a profile of how much AI you are using already in your visit in the supermarket. That is one thing we do on the online platform, but we also go to events. At the first year when we started the project, we had to do mainly online because it was COVID in 2021. We were still in COVID period, so we couldn't go much outside. But from the second year on, we managed to also go to events, and there we created an interactive booth, and we really went in conversation with people. And we also realized that helps a lot in getting these ideas from citizens and getting them to think about how AI could be beneficial for them, because we can start talking with them, starting from their interests, what matters to them, and then think with them, think it through, like how could technology get a place or be beneficial for them. And next to that, we also put a lot of effort in broad communication to general public. We have our social media, but we also have collaborations with the public broadcaster in Flanders and also a national newspaper. So once we have these ideas gathered, we cluster them to get started in co-creation sessions. For the clustering, an example on the slide is, for example, in the team of work, there's a cluster on personal planning. So all the ideas that, for example, work on personal agendas or personal planning are gathered there. And then we have around 34 of these clusters in total. And in the co-creation session, these form the basis to get started with the ideas and get into more concrete applications. And in these sessions, we bring together citizens, but also experts in societal challenges, experts in AI. We bring them together around a table to further define the scope of the issues, and then also the requirements of AI solutions and other things to take into account when these applications should be developed. And then after the co-creation sessions, for the next step, we have the open call, a project call. The project call is open to consortia that can consist of nonprofits and civil movements, local government, knowledge institutions, or IT companies. So it can be a mix of those, but it should be at least 2 different partners, 1 technical partner and 1 societal partner. So they have both the expertises in there, and they can work together to create a solution. To select the projects, it goes in 2 phases. First, there is the jury of experts, and they don't make the decision, but they do make a sort of pass or fail decision. So they they decide which of the projects can be good enough to potentially get the funding. And for the project that do get the pass, then they go to the citizens vote, and that is also twofold. We have a jury of citizens. That is a group of around 20 citizens that come together 2 days in a row to really discuss the project in depth. Also, the potential projects come there and pitch their ideas to the citizens, and the citizens can ask their questions, and then they discuss them further. And the same time, parallel to that, we have an online vote for a public prize on the website also, which is also made to be very accessible, and people can go there and vote on their favorite projects to also decide on one project that gets funded. And this way, the past year, every year, 3 to 5 projects have been funded for 125,000 euros each. So once they get funded, then in the last step, the project gets started and the AI applications are being developed. Also here, citizens are involved in the development. So citizen science is a crucial component in the project call, and these consortia have to prove that they will be working with citizens in their project as well. And that could be in different ways, like focus groups, collecting data, annotating data, or any other way. For this, it's a bit out of our hands, so we don't do this work anymore, but we do support them. We have regular intervision sessions where the project that are running come together. We offer them support on citizen science, on AI, and also on communication. And we also notice that the moments that they come together, they have a lot to share with each other, share experiences, and really also learn from each other, even though the project might be very different topics on very different teams. The fact that they all involve citizens and all have to work on an AI solution really connects them in some way. And what we also do is we use these projects that are funded as good examples of societal AI applications, and we use them in our communication and also to communicate to citizens how AI applications are being developed and what are the steps that are needed in the development of such an application. This is an example of one of the projects. It's called Waste Watchers, and this shows how the project came to be. So we started with 16 citizens that had actually shared ideas on litter monitoring using AI. So 16 citizens wanted to use AI in some way, one way or another, to monitor litter. In the co-creation sessions, the ideas became more concrete, and they ended on litter monitoring using image recognition. And then they, 2 organizations formed a proposal to use drones as a citizen science instrument to do this litter monitoring. So they handed in the proposal and they got selected for the funding. And now they are running, or they have just recently finished with their project. But they did very nice things, like they organized a roadshow, for example, where citizens could come in different locations to try out flying with a drone and detecting litter, or people who had a drone at home could also register and do the drone, go on their own to use their drone to gather data on the litter next to the river. So that is how the project works in a nutshell. So of course we had to engage people in different steps of this project. This shows a quick overview of the evolution over the years. So as I mentioned, we started in 2021, which was still in COVID times. So we had to do everything online. We really had to focus on creating our online platform and make it as accessible as possible, even though it is still, we really realized how much of a barrier it still is to get people to your platform and then even share ideas. It's a really high barrier. So we tried with our online brainstorm sessions and things like that, and it worked. But in the second year, we managed to go outside and talk to people, and we realized it works just so much better to really get to talk to people about topics like this instead of expecting them to come to you and share their ideas, of course. So this really helped to go to the people, get in conversation with them. We also started organizing more workshops and lectures. We created an interactive booth to take to different festival and events. Then the year after that, we focused on AI literacy in schools. We created a teacher package and teach the teacher workshops to teach about AI in schools. We also have an AI card game that we created and that we send out for free to schools to try. So that was in 2023, and then last year, 2024, we shifted the focus a little bit more to low literate groups. So we were still working with teachers, but it was teachers within organizations for low literacy people. And we also, another thing we did is to go on the streets, just talk to people on the streets. And for that, we created a theater show on the streets. So it's a street performance. This shows an example of that. So the idea here is that we went to different market squares in Flanders in different locations, and we had a mobile installation with two actors, improvisation actors, and they played some sort of analog generative AI or analog chatbot, and people could ask for something in the chatbot, and then there's one actor in front and one is behind the screen, and then he had a lot of different goodies, and whatever people were asking, he was just coming up with different things to simulate what they were asking for. And it was a really fun way to get the conversation also going, and also there people were able to share their IDs. We had ID cards where people could then write down their IDs. This is the card game that I mentioned. So we actually created it in the first year already, but we really started using it more once we went to the schools. The idea there is that we you have to build your own AI solution by collecting the right cards and playing the right actions. And the solutions in the game are also based on ideas that citizens have shared with us before. So their names are also on there. So it can be played at schools or at home. It's suitable for children from 8 years old because we really made sure it has like a very attractive design and cute figures, but it also has a word of explanation. So it has some explanation of all the different terms on the cards as well. So if you're for children a bit older or those who have already played it a few times and they're interested to learn more, it's very easy to read just a few sentences about what they are doing exactly. And we also have a translation to English on this game since last year, thanks to a collaboration with the Adapt Center in Ireland. So that's really nice. This is the interactive wall that we have and bring to festivals. The idea there is that it is a quiz. It's an AI or not quiz, and there's a question that pops up on the screen. For example, a smart camera on smart cameras, does it use AI or not? And if you think yes, you have to go like this and put your arms in the air. If you think no, you cross your arms, and then there is a camera in the installation that detects your movements. So it uses AI to detect your movement, but it's also something that learns about AI. And this is something that is really attractive at festivals because people pass by, they see something happening, and they're always very interesting to see what is going on at the screen, and they want to try it themselves. And it's also a great conversation starter. Then the train the trainers I've mentioned. So we have both teacher packages and train the trainer sessions that we organize at schools or at other organizations. So we had first a focus on school teachers, and we were very lucky there with the timing because we were working on this just when the ChatGPT boom was happening, when everything was happening very quickly. So we were really lucky to have it just in time when all the teachers came and were looking for information and didn't know where to find any information on ChatGPT. Luckily, we had it ready at that time, so there was ideal timing for us. And then last year, we shifted the focus a little bit on the low literacy groups, and there we also focused on generative AI and a lot of media literacy, and also the focus on deepfakes, and just to make people aware of deepfakes, that it is a thing that they should be careful for. Nonetheless, also stressing what can AI do for them and how they can be helped with AI solutions. This is a quick overview. I will not go into detail on this at this point, but this is actually a table from the paper that we published recently. It shows the different activities that we have organized and how it matches with our different goals and the different settings within the project. So both one-way communication materials that we have, these are mostly the things that are on the website, and then also interactive materials like online things, and also the bookable activities. Like, for example, we have a data walk, or we have brainstorm sessions and things like that. To close off, some lessons learned about the project. One thing we learned is that it's very challenging to run the whole process in 1 year. Unfortunately, we only get funding for 1 year every year. So it's always a bit looking how we can do this within 1 year, because there's a lot to do in just 1 year. And the first 2 years, we really used the sequential flow. So we started with gathering the ideas, then we had the co-creation, the open call, and it all followed very closely after one another. Because it puts so much stress on us as a team and on everyone, all the potential partners that are working with us as well. We shifted it around a bit, and from 2023, we changed it to more parallel tracks. But the only reason we could do this is because we already had a lot of ideas gathered in the first 2 years that we then could use in the open call for the 3rd year. So we could open the call early in the year with the ideas that were already gathered from the first years. At the same time, we were still gathering also new ideas, but then all year round instead of just for a couple of weeks or months. A little bit about the future. So this year, unfortunately, we have some limitations in the budget. So, we don't have a funding call this year, but we will be able to focus on the sensibilization that will be there. We will still be doing the outreach. And we will be creating some time for reflection and valorization of the things we have already created the past years, and preparing for the future years. And one thing we will do this year is, instead of the co-creation sessions for solutions, we will have co-creation sessions both with citizens and partners that we work with to think about the future of the projects. So that will be very interesting. And then we hope to work towards more long-term funding from 2026. We don't have any security on that now, but we hope so to be continued. And then I would like to thank you for the attention. We have, as I mentioned, the recent paper. So if you're interested in that, it's in the special issue of Theory and Practice. So if you're interested in more details, you can definitely go there and have a read. Or if you have any more questions, feel free to contact me. Thank you.
Thank you very much, Karen. That was really interesting. And there's also been a couple of questions in the chat, some of which you might want to have a look at. Also, another invitation for everybody else to please start adding questions to the chat. I'm monitoring those, and I will bring them into the Q&A later. For now, I will move on to our 3rd speaker, Etienne Serbekamp. Again, I'm hoping I'm pronouncing that right. Who is a neuroscientist and citizen science advocate who studies the focus on the neural circuits of vision in fruit flies, and a lot more details where that comes from. I'm not going to explain it all, because I'm sure he'll do a brilliant job of explaining this to us. And his work focuses on bridging neurosciences with public engagement. So Etienne, the floor is yours.
Thanks a lot for the invitation and for the introduction. So I hope you can all see my slides. Perfect. I want to tell you a bit about like 3 projects that I was working on over the last 3 years, and more how I used AI as a tool to accelerate my projects, and how it also helped me to use it, creating new tools to use it, especially in neuroscience education and in citizen science projects, where we also were collaborating always with young citizen scientists, like mostly students and pupils. First, most of my projects are done in collaboration with and through Backyard Brains. So they are providing low-cost educational tools for high schools and for universities to do science experiments, to measure electricity in any kind of living things. And this is like my citizen science, science education, or science communication path that I took into like 10 years ago, But besides that, I work on the like fruit fly vision circuitry, and that I'm doing at the Max Planck for Biological Intelligence, and the LMU. I'm also having a science communication project where we did some eye tracking, and this is one of the 3 projects that I'm going to present now. For any questions, you can also send me an email, or no, just put them in the chat. So I just want to start with how we set up a good infrastructure. I think similar to Karin, like we had stuff already prepared before the big AI boom was already happening, and I think this was really good to work on with, and then we could use LLMs and all other AI tools to just automate processes, to streamline processes. And these previous projects, I would say, they were in collaboration with Dan. He is in Caltech in California, and there he went to a communal college to do some science education about recordings in all kinds of insects. So here you see a little like a preparation or an example of how, for example, one can measure the photoreceptor responses of a bee. I think, can I somehow give it like a pointer, maybe?
We can see your cursor.
Okay, you can see the cursor as well. Okay, perfect. Now, so here you have like a little preparation. So the students from the communal college, they were setting up the bee, and then you can connect a little wire to the eye of the bee, and then shine lights from different colors, like from an LED, and then measure the electrical signals. And with that, we were able to show that a lot of insects, for example, they have different sensitivities. They see more in the UV part of the spectrum of light in comparison to us humans, for example, that don't really perceive those colors and but see more in the red spectrum, what insects, for example, cannot do. And this we then also like wrote up as a initiative to that other communal colleges can do similar like approaches and analyze the data that you gather in a Google Colab. So most of the analysis that we were doing, especially in these kind of tele-education setups, was that we could gather the data on a Google Drive and then analyze the data in Google Colab, and then from different parts access the data, and then also use it as the like in communication with the students to show them how they can also analyze like big chunks of data that you can then collect with these Backyard Brains tools. Another study beforehand that we did to get an experience in how to include the classroom already in a study was that we collaborated with Jessica Shin, who's a high school teacher. And with her students, we wanted to see how students approach the scientific questions in general, and how they want to find out whether plants can learn, which was trying to like reproduce a controversial question in science in general. And so we got the experience of how to gather big chunks of data with these electroretinograms, the sensitivities of the insect eyes, and also found like a nice connection to schools that actually doing science like in a school setup is a really nice way to also have an organized structure that you can set up your research questions for a long like year, to go like through one year of a school year. And so we set up to investigate the electricity in plants. So the electricity in plants that they're using, these electrical discharges, as we like they're called action potentials, is known in two plants especially well, which are the Venus flytraps and the sensitive mimosas. And when touching these little hairs in a Venus flytrap, you actually generate an action potential that is really easy measurable. And you just have to put a wire on around a plant, and you touch the trigger hairs, or you touch a sensitive mimosa, and you will get those discharges. So in collaboration with the school in Santiago de Chile, we wanted to find out whether the students can become the authors of a scientific publication and guide them through the whole process and be like a supervisor as it would have been in the lab, but they were just in the classroom and meeting every week to do these kinds of experiments, because we thought that they're actually quite easy to do, reproducible, and plant electrophysiology is a really understudied field. Here again, the setup for the students was really easy. So we connected like now via Zoom. They could set up different plants. We wanted to make like a plant electrophysiology library and used as many different species as possible. And then they could wire around the plant and used a stimulus, in this case, a flame. Why did we use a flame? That it is known, for example, in the tomato, that plants have electrophysiological responses towards these kind of damaging stimuli. It's called the wound potential. And they are similar to these action potentials that we know from the Venus flytrap and the sensitive mimosa, just as they last even longer. And with the help of the students, we could now measure a really big set of different plant species to find out whether there are more plants that are yet unknown that actually have these signals. And with one of the first plants that we investigated, we already had we hit the jackpot, let's say, because the basil has these wound responses as well, and is already well studied in how this wound potential is generated in a more chemical fashion, but actually measured and published has not been before. So we already had like a real novelty that we knew that we can add to plant signaling or plant electrophysiology with the students, and the data was collected by students and also analyzed. And this is now where AI was a big help. Again, also these large language models again, is that when you start collecting these huge amounts of data and recordings from individual plants, and you need to find out whether the signals, they coincide with when the flame was applied. I was writing my own scripts already beforehand, but then the use of the LLMs to accelerate and to review my code was really helping a lot. And also I could then show the students how to use these tools in connection with the Google Colab, so that they can already collect their data, upload it to a drive, and then use it as a analysis tool. And so in that way we could match the data, we could find the signals when they applied the flame stimulus. We could align all the experiments they did over several days and with the different plants. And in that fashion, we could then generate figures together where we collected the data from all those different plant species and found whether we found more of these wound potentials or not. And in total, after 400 recordings and I think 7 months of school, where we met every week to do these experiments in parallel, we saw that in 9 plants, we find those wound potentials or action potentials. So we could use the fly trap and the mimosa as our control experiment because these are well studied. And the tomato and the sundew, we also knew that they have these wound potentials. And so we could reproduce these experiments, but found also 5 new plants where we actually saw this wound potential and could publish these data with the students. So the students were our first authors on the paper. They helped with the writing, they helped with the analysis, they were involved in the whole publishing process. They knew now with 17 years old already what it's like to be a scientist. So I'd say they went through the school for already naming themselves a proper scientists, and it was just a really nice experience, and they were just so motivated to also like get such a big deal done in such a short amount of time, that it was also pushing big waves in the media. So there's a news article in El Mercurio, which is the biggest newspaper in Chile, and we also had some other media attention and even our first citations just within a couple of months. So I think this was a huge success, and in this case, AI was really helping with reviewing code and also helping the students to start with coding. This is the publication, and another thing where AI helped is in creating a bit artistic representations also from these electrical signals that we measured, and you can see this here in the top. Unfortunately, it didn't make it to the cover of the journal. We published it in Plant Signaling and Behavior, which is a really prestigious journal for plant biology. But I also really like this picture, which is the collection of all the action potentials and wound potentials that we measured. So next, I wanted to quickly present just a short citizen science outreach initiative that we have with the LMU. And there we did some eye tracking and presented maps of the IPCC of climate change scenarios, and then added some questionnaires of their low carbon behaviors, whether they have a climate anxiety, and wanted to see whether we can actually predict the climate anxiety levels due to the questionnaire outcomes, and also due to like how people were looking at those different maps. And here we could then already build some models using those as predictors. And it's not like that just through looking at the eyes of the people we can now say like how climate anxious they are. It's not like that impactful, but just to also mention like how AI was actually helping in that process is that with a short amount of time, I could also start using these regressor models and come up with the data for a lot of people to like set out to build those models and helping me with the data analysis. And finally, just as a short idea and also like a short detour, maybe like how Backyard Brains actually started, is we want to give students the possibility to do neuroscience, so to measure these electrical signals. So I gave you an example of the plants, but originally it was always done in the cockroach leg, because the cockroach leg also has neurons, and once you start touching those barbs, they fire action potentials. And these action potentials look like this. So they're like millivolts of discharges that you can measure and that you can then analyze. And like this, you can become a neuroscientist in a really easy fashion. But the problem is that not everyone has a cockroach, and not really everyone can or wants to do such an experiment. And that's why I came up, or why we came up with a thing called the computational spiker box, which then in the end has the possibility to recreate these action potentials where you normally need a cockroach or a cockroach leg, but now I only have to like press a button and can do this experiment at home without needing a cockroach leg. So having like an experiment of neuroscience in silico without actually like needing the animal itself if I don't want to do an experiment. And here AI was again of great help, because these are like biophysical models that run on a mini computer, like here, like this little Arduino. And I can quickly create code and quickly like program things that I did beforehand only just in a Google Colab environment again, but bring it also onto these educational modules that I can then use in the classroom to teach young students already really difficult ideas actually of how neuroscience works and how action potential, which is like the language of neuroscience, is actually like generated. And they can use it not only, they don't really need that box only, but with the help of these Google Colabs, they can also just have like these little graphical user interfaces to understand how different ion channels are actually generating these action potentials and how you can manipulate them, and what happens if they, for example, you get stung by a scorpion. If your neurons, one of these channels that they need for generating these action potentials will be blocked, and like this they can also understand how the neurons actually work. And here I used AI again to use these kind of illustrations in the classroom setting to show kind of little history stories, and having different cards printed out so that they need to find the different toxins from different animals and how they actually influence our nervous system. And so they can use the computational spiker box, change their conductances of the ion channels with like little knobs, or just use the Google Colab and these cards, and then they learn how an action potential is generated kind of without using a cockroach leg. So to end that up, so these were the three different projects where I used the power of like these new LLMs that they can just accelerate the processes. And I want to thank all the people that have helped in the projects. And again, if you want to see what else we are doing, visit our website, or you can shoot me also an email.
Fantastic. Thank you so much. It's so interesting to see all of these different perspectives on AI from our different speakers. We have some time left now for questions. So if I could ask our speakers to maybe switch their cameras back on so we can see what else is happening. I know some of them have to leave early, so let's just see how far we get. I have so many questions, and there's been some that I picked up in the chat already. Please keep adding them. But one thing that I saw pop up, even when we announced this event, was how do we use citizen science data for AI rather than just get citizen scientists or citizen science projects to use AI? And I wondered if any of our speakers had a vision on that. Maybe we can start with Dilek.
Yeah, thanks so much, Gifham. This is a very good question, and I think I covered it a little bit in the presentation that I have given in terms of addressing this local data and the lack of local data. Yeah, I think it's important. So we're all aware of the work that we do and how it could complement the data that we produce with our citizen science projects could complement a lot of the areas where there are large data gaps. But particularly what's important with citizen science and is the aspect of this going to local. So it could really go into the local. It provides the perspective of those individuals and communities for their own particular area and location. And that is actually very important in the context of AI, as I presented before. I provided one example, for instance, for plastic litter that Karen also picked up later. She was also talking about a plastic litter example. So that is one area definitely that citizen science data could cover, and we provided other ones. But what's really important is to focus on these aspects. So where the areas where the data are lacking. So especially, I gave the example from the global south where there are large data gaps exist, not only in terms of sustainability monitoring, but in general, also scientific research and so on. So I think as the citizen science community, we can really advance our work and research by focusing on those areas that are remote or doing really additional work. Probably for us, it's also related to funding and some limited resources we have in our projects is really try and reach out to those who are not really represented or who are underrepresented in scientific research and also in sustainability monitoring. So this is just a quick reaction on this. Thank you.
Thank you very much. Karen, again, did either of you have anything to add to that?
I think I'm following what Dilek said. I can add, the focus on the vulnerable groups and just the inclusion perspective to include all the groups that are usually maybe not involved in this kind of projects to really add in and have their data included in this AI applications, as we know, because of the bias. And yeah, that's all I can add about this.
That's fair, thank you.
My idea would be maybe to like the tools that we already have for recognition or that kind of exist and give us a pre classification. If we open up those tools that they want more feedback from citizen scientists to maybe even more refine the classification so that the models themselves and the architecture of the AI kind of like opens up to try to incorporate outside information better.
Right, thank you. I haven't seen many more questions in the chat, so very happy to get more from the audience, and also if anyone wants to raise their hand and ask a question now, we can certainly do that. For now, I'm just going to keep going with one more question that I had for Karen, which was that your approach with amai was very specific to that specific, like we have these AI projects, we want to sort of figure out what works for citizens. I wondered if you think that approach would be transferable to other areas. So for example, I'm working on a project that looks at participatory AI auditing. Do you think the work that you do in amai can help inform some of those other approaches as well?
Yes, I think so, for sure. I think the idea that we have behind this project is that we apply this to AI development, but it can be applied to any other difficult to grasp concept for citizens, to involve them in any difficult topic and combine the outreach component with having them involved in having a say in this topic. One thing we have thought about before is our offices. We are in the IMEC building in Leuven, where there's chip technology is their main core, to work around a similar project, for example, on chip technology. How can citizens think in the development of chip technology and how can they be involved in this? So I think the main framework can be the same in different complex topics, yes.
Thank you. So I'm just trying to follow the chat. Lots of people have to leave now because we're at the end. So I just want to quickly say we can continue with a couple more questions if people have more time and want to stick around. But I also want to use the opportunity, so long as you're still here, to say thank you for coming. This has been really interesting and it's been really well attended. I think we have hit that 100 attendees mark at some point during the presentations, and then people have started dropping off at the top of the hour, unfortunately. So thank you for being here. If you have more questions or want to have more of a discussion, please do stick around. And for now, I would say thank you and let's wrap. And then, I don't know, I want to open the floor also to our speakers to see if you have any more questions for your colleagues. People are very much dropping off at this point.
I think it's been very interesting. Thanks so much, Karen and Etienne, for the insights. I'm probably, after reading your papers, I'll be in touch.
Yeah, thanks a lot.
Yeah, thank you.
We have a hand raised actually, so let's get to if we still, for those of you who still have time, stick around for a little bit. Is it Tizian? How do I pronounce it?
Yeah, that's correct. Thank you. I just want to follow up on the first question, because how I got to understand the question is how can we make sure that AI models actually use the data produced or collected in citizen science projects? And of course, if you have your own AI software, you can train this software and then that's fine and that works. But how can we make sure that the software that everyone else is using actually uses this data? I think this is the question. And do you have an answer to that?
I mean, maybe I can try and answer from the first thing that comes to mind in terms of the work that I do with the National Statistical Offices and in the context of official statistics. A lot of the issues we have with these communities, they may be interested in citizen science, but first of all, they don't understand what it is. And second of all, they just don't see this as a long-term solution. And they also see a lot of different ways of collecting data. So no standardized, harmonized way of collecting data and using these data. And I don't know how it may be related to that. So maybe if we work on a little bit standards and in citizen science as a group and as a community, that could probably help. And also if we could improve the ways we approach quality in terms of of course, looking at the fitness for purpose of data. So I think in general, the communication is really important aspect as well here, but I will stop here to see if others have any comments on this.
I think now the implementation of also online search of where AI gets its information from, most important is to have the data accessible and like also findable for the AI to include it into its own reasoning. I think that's most important.
Maybe I think one thing I would add on that is that part of the issue is actually getting people who develop these AI to be aware of what citizen science data there is, because I think there's a little bit of a disconnect still between those two communities. Like citizen science community knows very well what the benefits would be, but I think as a community, we have a job to actually sell this or pitch this to those other communities as well and go beyond our... In German, I would say über den Tellerrand, but I have actually no idea how to say that in English. So thank you for that. Very good question.
No, just to add on that, I think Etienne also highlighted a very important point about, we tend to think that citizen science data are always open, but that may not be the case most of the time. And that has an impact, of course, of the uptake of these data. So maybe if you guys would like to have a 2.0 event of this one, because it seems that people are really interested and they want to discuss more, you might want to focus on the linkages between this openness and both openness in AI and openness on citizen science. I think these are really important. And Gefion, I totally agree with you when I said communication. I actually meant also that. And in this paper that I was presenting, there was a roadmap. So how we could build this kind of communication and linkages with diverse communities is really the important aspect, I believe.
Yeah, hard agree. We are 5 minutes over now, so I know some of you said they had to leave. So I would say, actually, let's look at maybe we can run another one of these in a year or so and see where we've gotten to and what else we have found. I certainly have a paper to present on that. How do you actually open up citizen science data for AI? Because agree with Dilek, that's not as easy as you would think. And licensing is a major problem. Let's not even start that now. Thank you all. Let's wrap here and let's stay in touch and continue this conversation.
Yeah, thanks a lot to everyone.
Thank you.
Bye.
Bye.
Thank you all. Bye.
Thank you.
Thank you, everyone.
Bye.